In the second video of this lesson, we're going to be practicing writing the equation of an ellipse. I've gone ahead and written 4 main steps that you want to follow in order to write the equations, but just know that each example is going to give you different types of information, so you're going to have to be a little bit flexible with the steps when you are going through the process. So the first step is usually to find the center, because that's going to be a big part of your equation. That's going to also help you to determine the direction and the equation you're going to use. So will it be x squared first, or is it going to be y squared first? And then you need to make sure you have the a and b values, because a squared always goes under the first fraction and b squared always goes under the second fraction. So knowing those values from the center to the vertex and the center to the co-vertex will be helpful. And then lastly, you're going to just fill in your equation with what's given to you. So in example 1, it says write the equation of the ellipse if the vertices are at 1, 4, and 1, negative 2, and then the co-vertices are at 0, 1, and 2, 1. So what I'm going to go ahead and do before I start following my 4 steps is plot what is given to me, just so we can visually see. Plus, that also could help you finding your a and b values. So the point 1, 4. So there's our first vertex, and then 1, negative 2, there's our second, and then our co-vertices at 0, 1, and 2, 1. So if you were to connect this, you'd have an ellipse. Notice that it's going vertically, which means that we're going to be using a y squared equation first. Okay, so, and we have to find our center. Our center is going to be halfway between all our points. So visually, it's going to be right in the middle of everything. So our center, step 1, is going to be at the point 1, 1. If you weren't sure how to find that, you could always use the midpoint formula, just like we did in the previous video, but sometimes it's really easy to tell from a graph. So our center is at 1, 1. We need to determine the direction. We already said it was vertical, so that's going to be a y squared equation, which means we're going to be using y minus k squared over a squared plus x minus h squared over b squared equals 1. And then we need to find our a and b values. So this is where the graph can be really handy, because we just have to count. So remember, a is from the center to the vertex. So if I count from my center to my vertex, that's a distance of 3. And then if I count from the center to the co-vertex, that's my b value, that's a distance of 1. So now I have my a and b values. Now it's just a matter of filling in my equation. So if I want to fill my equation in here, I'm going to have y minus 1 squared over 3 squared, which is 9, plus x minus 1 squared over 1 squared, which is 1, equal to 1. And there is our final equation. So again, it's important to find the center, know which letter comes first, and then find your a and b values. Once you have all of that, you just plug in to your equation and you're finished. Let's look at example 2, where we're given the foci at the points 7, 9, and negative 1, 9, and the co-vertices at 3, 12, and 3, 6. So again, I'm going to plot what I'm given just so we can visualize what we have. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we've got this first point, that's a focus, and then negative 1, 9 is the other focus. Okay. And then we have the co-vertices at 3, 12, so I went ahead and plotted that 12. So co-vertex here, and then at 3, 6, 1, 2, 3, 4, 5, 6. There's our other co-vertex. And remember, the foci are always in line with the vertices. So this is an ellipse that actually is going to be drawn horizontally, with our foci, of course, going left to right. So we need to find our center. Then we need to go ahead and find our direction, and then the a and b values. So our center is going to be halfway between the co-vertices. So if I have 3 to 12 halfway between that, or sorry, 6 to 12, halfway in between, we're going to be counting up 3. So let's see, 1, 2, 3. So the point for our center is going to be at the point 3, 9. And remember, the center should be in line with the co-vertices as well as the foci or vertices. So if it's not in line with them, then it means it's in the wrong place. So we've got our center. We already said that because this goes left to right, that means it's going to be an x squared equation. So we're going to have x minus h squared over a squared plus y minus k squared over b squared equals 1. And then we need to figure out what A and B are. Now, the problem here is that we don't have the vertices. We do have the co-vertices, so we can find that really quick. So the distance from the center to the co-vertex is 3. But what we're also given is the distance from the center to the foci. And remember, that's our value, C. So if we count from 3 to 7, that's a distance of 4. So this is where that formula we wrote in the first video, C squared equals A squared minus B squared, is going to come in handy because we need to find the A value. So if I plug in B and C, I'm going to get 4 squared equals A squared minus 3 squared. So we get 16 equals A squared minus 9. If I add 9 over, I get 25 equals A squared. So A is technically equal to 5. So now I can plug in everything I need because I've got my center, my A, and my B values, and that's going to give me x minus 3 squared over 25 plus y minus 9 squared over 9 equals 1. And we're finished. So if you're not given the center, you need to find that. If you're not given the co-vertices or vertices, then you're going to have to use the C squared formula to find those values, and then it's just plugging into the equation. I believe that's it for this example. If you have any questions about graphing or writing the equations, let me know. But the last video is going to be some practice of writing these equations in standard form. Thanks for listening.